All right, here we are with another example. We're going to um, find the rate of change of the distance between the origin and a moving point on this graph. So first of all, let's get an idea what this looks like over here. We have the sine wave, and the origin. So we have to find the distance between a random point here on the curve, and I'm gonna give the coordinates of that. We have x and sine of x. That's the point. Okay, and we want to find that distance. I'm going to call that, I call it d. I'm not going to call it d. I'm going to call it something else. How about how about L? Whoops! Ouch! That was not good. Okay, let's get that back in there. Okay, there's your sine wave. X sine x, and we were just talking about that let's see, okay, so there's our color. All right, now that distance is we can call it L, and this being a right triangle, we see that we have x and y, which is the sine of x. So now the distance in here from the origin to this point, the distance formula L will be equal to the square root of x minus 0 squared plus sine of x minus 0 squared. So it's that ordered pairs coordinates minus the other. So there's a difference between the x coordinates and the y coordinates over here. And that's our distance formula. Now, let's simplify this a little bit. This is going to be x squared plus sine of x squared. And that's the half power. Okay. So now, we want to find the rate of change of the distance between that point. So we want to find dl dt. Okay. And let's go ahead and start differentiating here. We're going to have a half x squared plus sine squared x minus half. Now I need a chain rule to give me the derivative of what's inside here. And that is going to be a 2x times dx dt plus 2 sine of x times cosine of x times dx dt again. Okay, so that one was tricky. So it's a squaring function. So you got to bring down the 2, lower it to a 1, and then multiply by the derivative of that sine of x, which is cosine, and then remembering that x is also a function of t. So we need that chain rule to give us dx dt out there. So this is everything. And now the dx dt is 2 centimeters per second, so we could fill that in. Notice also a couple other things. That 2 and this 2 and this 2, they will cancel since this is in the denominator. So with a little bit of straightening out, we're going to have 2x times a 2. Whoops, I don't want that extra 2, do I? Let me get rid of that, because I already talked about simplifying that. So let's start that. Let's take a step backwards. Okay, so the 2's are all going to cancel. This one, and this one. So we'll have in the numerator, we'll have x times the dx dt, so that's a 2x. And then over here we'll have the sine of x, cosine x times a 2. So another 2 sine x cosine x. And then down here, we're going to have square root of x squared plus sine squared of x. And that is our rate of change of that distance, which I called L, between the point and the origin itself.